Welcome back to another one of my critical points videos in the application of differentiation playlist. And I'm going to show you how to find the critical points of a function. Hopefully you've watched the other two if you don't understand it. If you're just coming here for practice, then just watch, I guess. But we're going to start off with this little sheet that I bring up in the past 2 episodes, and I'm going to bring it up in every episode I do on this. Critical points. And then people say it's same as critical number. It's kind of not. Critical number is when you set the derivative equal to 0 and then find the critical number, or you set the derivative to undefined, which then you find the critical number, and then you sub that back into the original function and find out if it's a critical point. Critical point is defined. It exists within the domain. If it comes out, if you put it in your calculator and it pops out a math error, it's not defined. It's not a critical point. If it pops out a number, any number, it is a critical point. Okay? And I'll explain that with this. Basically, if something does exist, which is when you set it to 0, you basically set the top to 0, because you only really do, you can do, when you're doing a single liner, you usually just set it to 0. But when you do fractions, you set the top to 0 and you set the bottom to undefined. And the reason you set the bottom to undefined, it's the same thing as setting the bottom to 0. Because if you look at fractions, when something does exist, it is defined. We're going to set the top to 0 because that's still defined. That still exists. Whereas if it doesn't exist, it means that there's nothing, which means that you set the bottom to 0, because you can always have nothing of something, but you can't have something of nothing. Now, if that confuses you, watch the first video, but if not, I'll go on to examples, or my one and only example for this video, which is fx equals x minus 4 squared over x squared minus x minus 4. So we have our u over our v, our function over another function, and the derivative is equal to u dash v minus u v dash over v squared. Now, I'm not going to go through, because I'll use up half a page just writing this stuff out, and it'll take too much time. So what I'm going to do is, I'm just going to, this light just got shit really quickly. Basically what I'm going to do is I'm just going to write it out after I simplify it. So instead of writing it out and then simplifying, I'm just going to write it out and skip a few steps. You can do all this, always do that steps, because you should be able to do derivatives before you're trying applications of derivatives. So that's a 40x plus 48 over x squared minus x minus 4 squared. Okay, so that is what you will get after you derive it and work it in. Expand the brackets and whatnot. That's what you get. Okay, so setting the derivative to 0 means that you will set the top to 0. So the top only. Okay, when you set it to undefined, you find the bottom is equal to 0. But we'll do that in a minute. Right now, the quadratic formula. I think that's the name of it. I forgot it in the last video too. But basically, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and this is what we're going to use to find our critical points. X equals negative b, negative of negative 40 is a positive 40, plus or minus the square root of b squared, negative 40 squared, minus 4 multiplied by 7, which is a, multiplied by 48, which is c, all over 2 multiplied by 7, which is a. And basically, 1x value, we're going to have 40 in the plus of this. You should know how to do quadratic formula before doing derivatives anyway. But everything, this will equal 256, and it'll be over 14. And the other x value will equal 40 minus the square root of 256 all over 14. Okay, so x equals 4. You sub that in, you get 4. And for this other value, you sub that in to a calculator and you will get 12 over 7. And those are your critical numbers for the top part. Now we're going to do the critical numbers for the bottom part. So when the derivative is undefined, or doesn't exist, you set the bottom to 0, and the bottom was x squared minus x minus 4 squared, all squared. Okay, so that's 0 equals, well, we're going to square both sides, and I've done it in previous videos, and hopefully you've watched those. But if you square 0, it's just 0, and if you square root something that is squared, it just comes out as that something. So if we squared this, it will cancel out that, and if we squared the 0 would stay the same. Anyway, this we use the quadratic formula to solve. Okay? Because we've got x squared, we've got an x, and then we've got a normal constant. Okay? Quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Therefore, x equals negative of a negative 1 is just 1, plus or minus the square root of b squared, which is just negative 1 squared. Negative 1 squared is just 1, minus 4 multiplied by 1, which is a, and then multiplied by negative 4, which is c, all over 2a, which is just 2 times 1. And just like before, one x value will take the positive, so it'll be 1 plus the square root of 17, because this equals 17, all over 2, and the other x value will be 1 minus the square root of 17 all over 2. Now, I'm not going to go any further with this, just because it'll just make it decimals and it'll be a pain in the ass. It's just much easier to hold the number as in this form. Okay, so what we're left with is x equals 4, x equals 12 over 7, and these values up here, I don't want to rewrite them because they'd take forever, and I'm lazy. But, so, we're going to sub them back into the original function. The original function we said was x minus 4 squared all over x squared minus x minus 4. Okay, so if we sub these back in, writing it out will take too long, so hopefully you can type it up in your calculator and prove it for yourself. But if you sub in 4, you get 0, which is correct because it may be 0, but it's still defined as 0, so it exists within the domain, which is good news. If we sub in 12 over 7, we get negative 32 on 17, which is still a tick because we got something. It's still defined. It's within the domain. But, unfortunately, for f, 1 plus square root of 17 over 2 doesn't exist. It pops out in your calculator with a pain saying mathematical error. So that's no. And for that last one, f 1 minus the square root of 17 over 2, that also does not exist. So basically, critical points are at x equals 4 and x equals 12 over 7 within the domain. So x equals 4 and x equals 12 over 7 are our critical points. Thanks for watching. I hope you learnt something and have a good day.